Okay, sorry about that. All right, so now it says satellite traveling in a circular orbit 1,600 kilometer above the surface of the Earth takes 2 hours to make an orbit. So now, what is one orbit?
One orbit is
2 pi. Wait, 6,400.
It's going to be 2 pi. It's going to be 1 revolution all the way around. So it's going to be 2 pi, right? Okay, so the radius of the Earth is 6,400. Remember when I say that's going to be standard? It's an approximation of the radius of the Earth. It's always going to be that. Okay, so approximate linear speed. Okay, so now, linear speed. I can go back and find linear speed. I'm going to have a couple things for that. Okay, so right here, linear speed satellite in kilometers per hour. Okay, so I'm going to add another slide to this. So Earth takes 2 hours. Let's see. 2 hours. What do you think 2 hours represents? Time. 2 hours represents my time. So I have t, right?
Yes.
So I'm going to say that t equals 2 hours. Very good. So let's list what we have. So t equals 2 hours. What else do I have? Radius. Okay, so radius is equal to how much? Try again.
Wait, 6,400 kilometers.
Nope, try again. Are we talking about the radius of the satellite?
1,600 kilometers?
Nope, try again.
800.
2 pi?
Is this the radius that we're talking about here? 8,000.
8,000.
Just 8,000, right?
Yeah.
Because I'm adding those two values together, right? How are you confused? Speak. Let's go.
Oh, yeah.
Say it. Why? We're talking about the big circle here, right? Okay, here's my donut, right? The donut hole is 6,400. The outside of the donut is 1,600, right?
Yeah.
So the whole radius of the donut is from there out to the edge, which is going to be 8,000. Okay, so do I have any other information? 2 pi. But what does 2 pi represent?
Revolution.
One revolution, but one revolution is going to represent what?
2 pi.
2 pi, yes, but what variable am I plugging in for?
Or V.
It's not a W. W would be the speed, right? W is the speed of the angle.
Theta.
It would be theta, right? Theta is the angle. Remember, a whole circle is what we're talking about. So 2 pi would be my angle there. So yes, it's a big angle. It's the whole thing. So theta is 2 pi.
2 pi.
So now I'm going to go to another sheet here. So it's going to be, so we have theta. Oh, man. Okay. Time is 2 hours and radius is 8,000 kilometers. So let's go back to this. No, we ain't doing concavity. Here it is. Wrong one. Sorry. All right, so let's go back. Okay, so I have what variables?
R, theta, and T.
R, theta, t, and I'm looking for what?
V.
V. I'm looking for V. I'm looking for linear speed, right? So if I have R, theta, and t, which one am I using?
The one in the middle.
Right here, right? I'm going to be using that one. Because that one has R, theta, and t together. So that's what I'm doing. Let's go ahead. Let's go back to it now. So it's going to be V equals R theta over t. V equals R theta over t. So V is equal to my R, which is 8,000. 2 pi over
2 hours.
2, right? 2 hours. Okay, so right here, I could actually just do some reducing to get it with the factor, with the terms of pi. So 2, so it's going to give me 8,000 pi. And if this is a speed, right? Speed, think of speed, miles per hour all the time. What is my distance over time? What is the distance I'm using to measure this?
Miles per hour, 60, wait.
Kilometers. This one's kilometers, right? It's kilometers, so it's km for hours, because my time is in h, right? Hours.
Oh, I thought you meant the other thing.
Okay, whenever I'm talking about speed, if you think about miles per hour, it's a distance over time. So the distance here is in kilometers, and the time is measured in hours. Okay, does that make sense?
Yes.
That's pretty simple, isn't it?
Oh, that's all.
That's it.
Everything's given.
Yeah. Basically, you just have to read through there and look at what variable you have and find out what variable you need.
Okay.
Make sense? Okay, I sent it out the new homework. Oh wait, I'm sorry, there's one more here. Part B says approximate the distance the satellite travels in 4.5 hours. Okay, so now, what stays the same? Nope. The radius, right? The radius. So the radius, so R is still 8,000. My T is 4.5 hours, right? Okay. The distance a satellite travels. Okay, so now the other one that we just did, that was at a specific time, wasn't it? Okay, so at a specific time, it was that. So I get my velocity is going to be 8,000 pi kilometers per hour. Okay, so I could use this one here, but if you notice, I can't use the same because it's not going to have the same thing. So I can't use the same t, and I can't use the same theta, because that means those two go together. Those two right there go together, but I can use my velocity. My v is going to be the same for all of these. My v is going to be the same for all these, because it said in the wording that one orbit is in 2 hours, right?
Yeah.
That's the reason why 2 pi and 2 hours go together. Because it said one orbit in 2 hours. So I can use velocity in this. I can use my velocity. So my v is going to be 8,000 pi km per hour. And distance. You guys remember, what variable was distance? S, right? Okay. Distance is S. So I'm looking for S. So S equals. Now let's go back. So that's the only one I could use, right? I only could use that one. So V equals distance over time. So I could find the distance now, right? Okay, let's do that. So V equals S over T. Okay, so now I'm going to use this slide right here. So V equals S over T. Okay, so 8,000 pi is equal to S over, what was my T? 4.5, right? 4.5 hours, right? I'm not going to put the hours in there, and I'm not going to put in my kilometers per hour because I don't want to confuse you guys with a whole bunch of other things. So we just need the numbers out of this. So now let's do the math. We're trying to get S by itself. So to get the S by itself, what am I going to do here? Multiply both sides by 4.5. There we go. So it's going to be this, right? So 4.5 times 8,000 pi. And this one's going to be in kilometers.
Did we put the cat?
No, don't put the pi. Just leave the pi.
Said pi.
Yeah, just leave it in terms of pi. So that means just have your pi on the end. 3,600? 36,000 kilometers is S. Now, it's kilometers because distance is only a linear distance. Velocity is my distance over time. That's why I would put kilometers per hour. But distance is only how far is it. Remember when we were talking the other day? So how far is it from here to Douche Bros? I'm going to say that's going to be 1 kilometer. In between here and Douche Bros is 1 kilometer. So I'm not going to say it's 1 kilometer per hour, right? That's just going to be 1 kilometer is my total distance in between here and there. Yes, I did. All right. Did I just get you? Right there? Okay. All right. Questions, concerns, complaints? All right, that's it. Okay. Don't forget, like and subscribe.
Yo, Mr. Louis, take a look.
What?